So I'm assuming that you all have the data. You'll notice that there are two spreadsheets, right? One is for the Malik 3 data, and the other one is for the total data. It's via PXRF. So Malik 3 is a proxy for bioaccessible, right? And it's not bioavailable, it's bioaccessible. And as you look through these data, you'll see at the very top of the spreadsheet, I'm looking at the Malik 3 one, you'll see some calibration data up here, and it just tells you that the calibrations were good for both cadmium and lead. You'll notice that our standard set for lead and cadmium were looking at very low values, much lower than we've usually done in the past, and that's because cadmium and lead in soils that are not like anthropogenically influenced by lead and cadmium and are just like looking at the naturally occurring content of lead and cadmium are pretty low, especially looking at it from the perspective of not the total, but what is bioaccessible. Okay, so our standard set's pretty low. We measured our Costa Rica soils, all of those, and then we also measured the Los Osos soil. You scroll down, you'll notice that towards the bottom, for our version of sample 21 is that's where we start with our blanks, right? And you'll notice some negative values down there. And those negative values are just telling us that when there was nothing, that no cadmium or lead in the solutions, right? The instrument had a hard time trying to find or measure cadmium and lead. So what we're going to use those for is to determine a method detection limit. And we'll just take the absolute value of those. Okay, so let's do that first. Let's calculate a method detection limit. And just to refresh your memory on the method detection limit, does anyone remember the formula for that? That is that's right, but that's for accuracy, right? Like measured over known. But for method detection limit, right, it's the mean of blank analyses, which we did 10, standard deviation of those blank analyses times the student t-test, one-tailed t-test where alpha is 0.01. So here is, so it'd be good for you to just have that formula in the back of your mind, because I'm going to move on to the student t-test, and it's in your notes somewhere too. So the student t-test is here. What is our value for the t-test alpha 0.01? Two 2.764 or 2.821? It's 2.821 because we use the degrees of freedom of n-1, right? So it's 2.821 is our student t-test value. If we go back to our data over here, what I'm going to do is take the absolute value of our blanks. So I'm just going to create, and I think you have it probably on your spreadsheet where it says lead and cadmium, and then it probably has some numbers below those. I think that those are wrong, actually. So all I'm going to do is insert a formula that says equals ABS. And then I am going to put a parentheses and select the first lead blank, and then close the parentheses, and then do the same thing for the cadmium blank. And then what I will do is scroll down or fill it down to capture all, or to get that formula to cover all my blanks. And then below them, all I'm going to do is I'm going to calculate an average, and then a standard deviation, and then the MDL. All right, so just use those values to calculate those things. And then if you don't remember the formula for method detection limit, I'll remind you of that in just a minute. The method detection limit is the average or the mean plus parentheses standard deviation times the student t-test value, which is 2.821. All right. Got similar values. So then what we want to do is remember these values here for lead and for cadmium and look at all of our data and compare all of our data to those values to see which ones are above and which ones are below the method detection limit. But I have some stuff that's kind of in the way, especially right here. I got my CCV standard 3 is these values. So I'm just going to move that over here. And do I have that anywhere else? No, I don't. All right, so I am just going to make a column up here that says MDL comparison. And I'll have one for lead, one for cadmium. And what I'm going to do is take the measured value and I'm just going to say equals that measured value for whatever the sample is. And I'm going to subtract it from my method detection limit, which is here. And in order to tell Excel, you probably know this, right? In order to tell Excel to always compare it to cell H51, you just put a $ in front of the letter and the number. And if I have a negative number there, that just tells me that it's not above the method detection limit. And after you have those values, you just take that formula and compare it to all your other data. And because it kind of butts up to my method detection data, oh, actually, I need to move that down here. You know what I'm going to do? I'm just going to make my method detection limit data red so that I know that that's different stuff. All right, any questions? That makes sense why we did what we did? Yes. Fantastic. So do we have any negative values in our lead column? I don't see any. Do you? Do we have negative values in our cadmium column? We do, right? So when we do, I'm just going to delete that value from the bolded cadmium column that's in milligrams per liters, right? So just go through it and delete it if you have a negative value. Okay. Feel good about what we did?
For the standard deviation, you're just using the regular standard.
standard deviation P. Are you all good? Yes.
Sorry, you deleted it in which row? The next
So
row?
the place that we're going to do all of our calculations is in the bolded columns. And so I just compared my MDL comparisons. So whenever I had a negative number over here, I deleted it over here. Okay. And so we only have that for cadmium, right? In those places where we have deleted values. Thank you for saying thank you. So now I don't need this information anymore. I'm going to keep my method detection limit calculation here, but I'm going to get rid of everything else because I don't want it anymore. I'm just going to delete that. Delete that. And then what do you want to do next? That's you. All right. I'll decide if you don't want to decide. Let's calculate a limit of detection, which is what the ICP, well, what we get from the ICP, which is the lowest limit that the ICP can detect. Okay. So the lowest limit that the ICP can detect is based upon our background equivalent concentrations, which are up here, and based upon our relative standard deviations. And our relative standard deviations are here. Okay. So background equivalent concentrate, or sorry, the LOD formula, I'll show you it. Here it is right here. So it's the LOD equals background equivalent concentration times 3 times the relative standard deviation divided by 100%. Okay, so it's BEC times 3 times RSD divided by 100. I'm just going to put that formula in. Okay, so those values are higher than I would think. So right next to this, I'm just going to put units question mark because I'm not sure if BEC here is in parts per million or parts per billion. Okay, so I'm just going to put a units question mark there and we'll come back to that. But for here, the units here are milligrams per liter for our method detection limit. That's good to remember. All right. Now then, after we calibrate, what's the next thing that's done? Calibrate, and then we check the calibration, right? Yes, but we do a different one, slightly different one. It's called initial, right? Initial calibration verification. So our ICV values for lead is a negative number. For cadmium is 0.002 right here. Our standard set was this information right here. And so since we got that negative number, we can't calculate a recovery for it. So I'm just going to, for lead, I'm just going to say that it's Na. But for cadmium, we do what Liz said. We do the measured over the known. So the measured is 0.002. And can anyone tell me what the known is? The technician called it CCV, but it's not a CCV, it's our ICV. And calibration standard set for cadmium is 0.002. So the known is 0.002. And it's good. Thank goodness, right? So make that a percent, 105%. Next one is we're going to do what Shannon said. We're going to go and look for our CCVs and make our comparisons with our CCVs. So we want to calculate recoveries for cadmium and for lead. And the first one that we're going to do is this place here, which is Excel row 29. And the standards are for cadmium 0.002 and for lead 0.1. So we just want to do measured divided by known, right, for those CCVs. So I'm just going to put that in. There's the measured divided by the known for lead is what was it? Was it 0.1? Do you remember? Tony? 0.1. Okay. And then for cadmium is 0.002. And we'll make that 100%. Then I'm just going to copy that and come down to the next time that I determine the CCV, which is here, bottom. Questions? Cadmium is 0.002 is the known. Lead is 0.1. Yeah, 0.1. Okay. What do you want to do next? Me to choose? All right, I'll choose. Well, if we go to our QC area here, every time we measured the recovery of a dilution and we did a replicate. So what we can do then is determine our recoveries of our dilutions. And then after that, we can determine the percent relative difference of our replicates. So let's do the recovery of our dilutions first. So in this case, we have a 2 times dilution of sample number 4. Sample number 4 is up here. And all that I'm going to do is I can't determine it for cadmium because our cadmium value is below our method detection limit. So all I'm going to do is do my diluted sample times the dilution factor divided by the undiluted sample. So in other words, my diluted sample for lead is here, right? It's 0.0496 times 2, because that's my dilution factor, divided by my original, which is sample number 4. Sample number 4 is right there. And I'll hit enter. Oh, that's nice. -%. Okay. So I'm going to, even though it's not going to be totally right yet, I'm going to copy that formula and I'm going to scroll down to the next time I did a dilution, which is in Excel row 45. So I'm going to paste that there, and it's not going to be correct because because the sample that we diluted was sample number 6, right? So I need to go and pick my undiluted sample for sample number 6 for lead, which is this one here. And we can't, unfortunately, do it for cadmium because the diluted measurement was below our detection limit. So all we have are values for lead, unfortunately. But you just got to go with it and be okay with it. and let it go. All right, what do you want to do next? Or do you want me to pick? Yeah, we can do, do you mind, Shannon, if we do the relative difference first? You don't mind? Okay. So let's do the relative difference between our replicates. After we do that, we'll do our relative standard deviation of our duplicates, right? Duplicates are at the method level. RDs are at the instrument level. All we're doing so far, except for a determination of the method detection limit, was instrument level quality control. So here we have at Excel row 28, we replicated number 12, right? So for this formula, we're always taking the absolute value, right? And the formula for percent relative difference, you probably have it memorized in your minds, but it's this one, right? We have the absolute value of the difference between our two samples divided by the average of our two samples. Right. Right. So you can go ahead and do that formula for your replicate measures for sample 12. It doesn't matter which one you pick first. I'm just going to these ones first. Then make it a percent. And then you can do it across like that. And then do it in the other place where we did it. You can copy the formula and then you got to just edit that formula. You good? I'll give you a little more time. Yeah. All right. For the next thing, I think what'll probably make it the easiest to do is to export our data to jump instead of do manual calculations. And so I think that the way that we should group it is by the farmer description stuff with an inclusion of the soil type also, if that makes sense. Or maybe we could do this. Let's do this. Let's copy this spreadsheet and let's just put it right next to it. And I'm just going to call this Malik 3 for RFD. And what I'm going to do in this case is for the CR1, 2, and 3, those are sterile soils. So all I'm going to do is just move my label over here, right? So I'm just going to call this sterile, sterile, and sterile. And then the other ones, CR4, CR5, and CR6 over here, and call that sterile, sterile, and sterile. And the reason why is because I'm going to take this column right here and have that be my label. And so when jump recognizes that, it's going to recognize this as my label. Makes sense. And then fertile 1. Fertile 1. Fertile 2. Okay. Then what I'm going to do is get rid of all the stuff that I don't need. And I don't need like this QC stuff that we did before, right? So I'm just going to get rid of that stuff. And I don't need my blanks either. So get rid of all that. Right. So what you should have is just values for your sterile or your Costa Rica soils, your Los Osos A, BTSS, and Holland A and Holland BT. Yeah. Right. So I just got rid of all the crap that I don't need. Okay. So then I'm going to open up Jump and I'm going to import this into Jump. Before I go to Jump, though, I'm just going to copy this. And make a new data table. And I'm going to edit and paste with columns names. And then I want to make sure that it's got my data correctly. Right? Right. Okay. I'm going to save this first. And I know it's like almost time to go, but I'm going to save it. I copy the data in Excel. And then when I have my data table open in Jump, I go to edit and paste with column names. Thank you for saying thank you. All right. So you remember what we do? We just want to some descriptive statistics. Before we do that, make sure that your data are nominal for soil and numeric for lead and cadmium, right? Then analyze. Remember? Tabulate. Is that what you're going to say? No. Anna, you were going to say that. Okay. Analyze, tabulate. Yeah. For sure. So once it's open, you go to edit and paste with column names. So you copy it in Excel, right? Just the data that you need, and then you paste with column names. And that should do it.
Okay. Some of the values
Have the dot. Good question. So the question that Kai asked is great. Why do we have some dots? And we have some dots here for cadmium because those are the values that we deleted because they are lower than the detection limit, the method detection limit. Which was for cadmium. Cadmium's method detection limit was 0.00045. and lead's was 0.032. Okay. And I'll just show you this real quick. I know you got to go, but I'll just show you real quick and we can revert to it later. I want relative standard deviation. I'm going to put my soil there. I'm going to put lead up there, and cadmium right next to it there. And then if all I want is relative standard deviation, that's the same thing as the CV. Drop that right there, right? Drop that right there. There we go. So then all I want is the range of those, right? So I got the range pretty easily. Goes from about, I think this is the lowest one, 2.45 to 55.06. Terrible precision. But probably because the values are low. Right, that's why. We'll come back to this next time, which is going to be on Thursday. Okay. Okay. Have a great afternoon. Thank you for your attention. Thank you for saying thank you when you said thank you. I'll see you tomorrow.
I am hoping to be out of town on Friday.
You are.